Hello everyone. Welcome to the mechanics class. Please confirm if you are able to hear me properly and see my screen so we can continue. Hello? Yeah, okay, good. So, um, like from last 3 classes, we are studying mechanics and we are focused on the statics part. We understood the concept of equilibrium. We have also understood the concept of friction, and we solved like a lot of problems. The previous session was dedicated for solving the problems, and while studying the concepts as well, we studied a couple of problems as well. Okay, in the today's session, I am going to start another point in the same statics part, and that is analysis of trusses. Okay, um, so here we'll understand how the truss will look like, how the truss structure forms, and how to find or uh, how we can analyze the truss structure under the action of loading. Okay, what are the different methods to calculate load at in any member of the truss? So that is the overall idea about the today's session. So it will be a mix of theoretical background for the trusses as well as the numericals on this topic. Okay, and as always, feel free to stop me if if you think you have to write on the slides, or if you have any doubt, feel free to ask me. Okay, so with this introduction, let's write down heading analysis of trusses. Write down heading analysis of trusses. Just give me a minute.
Hello, sir.
Yes,
Sir, last problem, I cannot solve this problem.
you were not able to solve it. Okay, no
Yes,
so
sir.
okay, then is it fine? Will if we study it in the next session? Uh, mm, I can provide you
Okay,
the
sir.
solution if you ping me on WhatsApp. I already have the solution of that. I can send it to you. And if you still find difficulty, I will solve it in the next class. Okay.
Okay, sir. Okay.
Yeah, yeah, yeah. In the meantime, you just Ganesh ping me on WhatsApp. I will after the class. I will send you the solution. Okay.
Okay, sir.
Okay. Down heading analysis of process. Okay. So draw this figure. Okay. Draw this figure. And maybe let's say some these are some loadings. So AB is a beam, or A and B are the supports, let's say, and the other points are like C, D, D, F, G, H, I. Okay, so draw this figure. Okay, we got a comment from Madhu. Yes, I'll share solution on WhatsApp group directly, so you can go through it. Okay, and if you still find difficulty, I will help you with the solution in the next class. Okay, so draw this figure. So what is meant by a truss structure? A truss is a structure containing members undergoing axial force only. So it's a structure undergoing axial forces only. Okay, and joined at various joints which behave like a pin. Okay, okay. The forces acting on the trusses are transformed to the supports through these axially loaded members. Forces acting on the trusses through these axially loaded members. Okay, so write down these sentences. So basically, what we understand from these sentences is a truss is a structure containing members which are undergoing axial forces only. So axial compression or axial tension. Okay, so for example, here the all the members such as let's say this AC, AC, CD, DE, EF, or let's say AG, GH, HI, IB, or let's say CG, GD, DH, HE, EI, IF, and FB. All these are members. Okay, and these members are undergoing some axial force. Okay, either compression or tension, and they are connected by joints. You can clearly see we have at point A we have a joint of these two members. Similarly at point C we are joining these three members. Okay, similarly at point G we are joining these four members. So at some joints we have two members we are joining, some at some joints we are joining three members, at some joints we are joining four members as well. Okay, so and these joints behave like a pin joint. Okay, and the forces acting on this trusses, so whatever forces we are applying on this truss structure, they are transferred to the supports. So basically all these forces which are applied on the truss structure are carried by the reactions or let's say are carried by the supports which we are providing to this structure. So here at point A and B you can clearly see at point A we have given one support, which is let's say hinge support, and at B we have given a roller support. So for in this case you can say point A and B carries all the load which we are applying on the structure. Okay, and this is transformed through all these members to the supports. Okay, any doubt till this? At least I hope you understood that truss is made up of members and joints. Okay, and these members are axially loaded. Okay, either they can be in tension or in the compression. Yeah, feel free to ask if you have doubt till this. So imagine that you are applying this kind of loading on this. So what will happen? Can you, let's say, imagine like this will bend something like this, little bit downwards, and this will also bend little bit downwards. Maybe let's say I'll use another pen. Yeah, this one. Can you imagine like it may bend like this because of the load, little bit. Yeah. So because of this, what will happen? The the members which are on top, okay, which the members which are on top chord here are undergoing the compression. Okay, these members will undergo the compression, and the bottom chord members will undergo tension, because you can clearly see there is little bit of expansion and here it is little bit of compression. So because of this small bending, so the top members you can say are under compression and bottom will be under tension. Okay. So these are the some basic things you should know. Now look, take a small element of it. Let's start with a small element rather than this big figure. Now I'll draw a small figure of it in the next slide. This is one element of it, right? Or this is one small, a single truss, you can say. So in order to make a truss, a single let's say element or single truss, how many joints and how many members are required? Okay, you can clearly see 3 members and 3 joints are required. So truss requires minimum 3 members and 3 joints. But if you want to, let's say, um, make any additional joint here, how many members you need? You need only 2 members. Are you following? So additional number of joints, if you want to make, uh, you need only 2 members for it. Okay, so for additional joint 2 members are required. Okay, if I want to make one more joint, I need 2 members again, one like this and one like this. So for every additional joint we need 2 more members. I hope it is clear till this. Okay, so let J be the total number of joints in the truss. Okay, so how many will be the additional number of joints? Additional number of joints will be, if total number of joints are J, then additional number of joints are J minus 3. Do you agree? Because for apart from this 3, total number is, let's say, 5 joints, then 5 minus 3 is additional number of joints. Do you agree? Is it clear till this? To make a single truss we need 3 joints, and if J is a total number of joints, then J minus 3 will be the additional number of joints. So how will you calculate the total number of members? Total number of members in the truss structure is equal to 2 times J minus 3, that is, or let's say start with 3. We need at least 3 members to make a single truss, plus how whatever number of, let's say, additional joints are there, multiply by 2 should be the members. Okay, so this is how we'll calculate the total number of members. Is it clear till this? Is it clear, this equation number 1? Feel free to ask if you have any doubt. And so let's call total number of members as m. So we can say that m is equal to, solve it further, it is 2j minus 3. Okay, so let's call it as equation number 1 now. So in order to make a stable and determinate truss structure, we need number of members equal to the 2 times number of joints minus 3. Okay, Shrujana, I will repeat it once again. Listen carefully. Okay. Let's start with the basics. In order to make the single truss, how many members are there? 1, 2, and 3. 3 members are there, and 1, 2, 3 joints are there. I hope it is clear, at least first sentence. Okay. Now, for any additional member, so if I want to add any additional member to the truss, so additional joint to the truss, for example, okay, for this additional joint, I need 2 more members. Okay, this is 1 and 2. Okay, similarly, if I want additional joint, for this additional joint, I need 2 more members. This is 1 and 2. Okay, so for each additional joint, or for every additional joint, we need 2 members. I hope it is clear till this. Okay, so so similarly, if this additional joint, we need 2 members for it. So if j is a total number of joint, okay, j is total number of joints, then additional number of joints are j minus 3. Additional number of joints are j minus 3. Look at this figure which we have drawn. How many total joints are there? 1, 2, 3, 4, 5, 6. So out of the 6, 3 are the basic joints, and the remaining 3 are the additional number of joints. Okay, so is it clear till this, Shrujana? Similarly, in the last slide, let's say 1, 2, 3. These 3 are basic joints, and apart from that, 1, 2, 3, 4, 5, 6 are the additional number of joints. Okay, so I hope till this you understood. Now, if you know now the additional number of joints, then total number of members can be calculated by 1, 2, 3, these 3 members. Okay, and how many additional joints are there? J minus 3 are the additional number of joints, multiply by 2. Okay, so if we have 10 total, let's say 15 joints, okay, in a truss structure, then 15 minus 3, that is equal to 12, are the additional number of joints, and total number of members in this case will be 3 plus 12 into 2. Okay, so it is 24, it is 27. Okay, I hope it is clear now. So I have just simplified this and written it. Any doubt till this, feel free to ask. So whenever any truss structure follows this criteria, that m is equal to 2j minus 3, then we'll say the truss structure is stable and determinate. If m is less than 2j minus 3, so for example, if I don't have any let's say joint, if I remove this member, what will happen? If I remove this member, what will happen? Because of this loading, this may fall down, right? Or let's say it may, depending on the loading, it may distort a little bit. So in order to have, or let's say if I remove this just by applying force, there is a chance that it will distort. Okay, so it is very important to satisfy this criteria 2j minus 3 if number of members are less than 2j minus 3. So here if I remove this, then this is, if you apply force, it will fall down, or even with gravity also it will fall down, right? So if I even remove this, this will come here, and if I apply force, it will distort. So for a stable truss structure, m has to be equal to 2j minus 3. M is less than 2j minus 3, then in that case we call it as an unstable truss. Okay, so this is a stable. Okay, and determinant. Okay, and there can be case that m is greater than 2j minus 3. In that case also, it's, you can say, redundant, or it is stable but let's say indeterminate. Okay, stable and indeterminate. Okay, so it is like a simple, let's say, mathematics. If you focus, if you let's say take an example, in order to solve a simultaneous equation with a two variable, how many equations we need, Ganesh? If you have two variables to solve, how many simultaneous equations you need? You need two equations, right? But if I give you, let's say, mm, more than two equations, what will happen? If I give you three equations and I ask you to calculate the uh, three simultaneous equations, and if I ask you to calculate just two unknowns, in that case, how the let's say, how the answer you will expect? And similarly, if I give you just one equation and ask you to solve the two unknowns, whether you will be able to calculate? No, right? So it's a similar kind of stuff. Stable means like you can easily analyze the system, and the system is stable because we don't have any extra or any less number of members. If m is less than 2j minus 3, it is clear that we have less number of members and it is no more stable. You can imagine by drawing the figure. Okay, removing those members. But if you add any extra member to this, what will happen? Then it becomes indeterminate. It will be stable, okay, because you are adding members more than required. So it should be stable, but it is redundant, or let's say indeterminate. For example, you might have studied in theory of machines. Okay, um, let's say if you have certain links in the, okay, so for example, E1, 2, 3, 4, 5, and 6. Okay, suppose this is a mechanism. This mechanism is consist of the links. Okay, let's call this link as A, B, C, D, E, F, and G. Okay, let's consider this is grounded. So if I remove this, let's say link, okay, and these are, let's say, one single link, for example. Okay, if even if I remove this center link, there is no change in the behavior of the overall mechanism. Do you agree? If whatever this rotates, this will also rotate. Same, let's say, same output you can expect. So in this case, you can say this is a redundant link and it is not required. So that is the reason whenever we have more inputs than, let's say, the required ones, we call it as indeterminate, or let's say we can call it as a redundant. Okay, I hope it is clear, Abhishek. Sanjeev, we got one question. It should be solved by force balance and moment balance. Yes, Sanjeev, we are not yet there. I have not given any problems to solve you. Okay, I'm just introducing you the what is truss structure. We are not at the stage of solving the truss structure by force and moment balance. But it is correct that uh, in mechanics we deal only with this, forces and moments. So the truss problems should be solved with the forces and moments only. Yes, of course, stable structure, and it has to be solved by using moment and force balance. Yes. Okay. So whatever problems which we'll be studying, they will be stable structures only. Okay. Then only we can solve it. Okay. I hope it is clear to you all. They'll not give unstable truss structure and solve you. Okay, ask you to solve. So all the problems which we'll be studying are the stable and determinant truss structures. I hope it is clear till this, the introduction about the trusses. Now, can we move towards the analysis of the truss? Okay, so write down heading analysis of the truss. Okay, so there are two methods. Okay, one is method of joints, and another one is the method of sections. Okay, let's start with the method of joints first. Method of joints, and write down little bit theory here to solve this kind of um, uh, the problem, or we how to use this method. Step 1, determine the support reactions. Determine the support reactions. Reactions due to external loading. Loading. Okay. Using equations, by using equations of equilibrium. Okay, what are the equations of equilibrium? Summation of all forces in x direction, summation of all forces in y direction, and summation of all forces in, summation of all moments, 0. Okay, step 2 is analyze the truss joint, or let's say analyze the truss joint by joint. Joint by joint by drawing a free body diagram. Okay, by drawing a free body diagram of the joint, and finding the unknown forces. Finding the unknown forces of the members. Forces of the members meeting at the joint. Joint using summation, using equation of equilibrium. Equilibrium equations. Okay. So write down this. Is it clear? First of all, first step is determine the support reactions due to external loading by using the equations of equilibrium, and then analyze the truss joint by joint by drawing the free body diagram, um, and finding the unknown forces again by using equation of equilibrium for the members which are meeting at the joint. Okay, so let's try to solve these questions one by one now, so you'll get idea what I'm talking about here. Yeah. Okay, can I proceed to the next slide? Are you done with this slide? Hello? Take a simple question. The axial force in a bar CD of a simple truss supported and loaded as shown in figure. Figure below. Okay. Options: 1000 Newton, 1154 Newton, 1500 Newton, 750 Newton, and the figure looks like this. -30° angle, 60° angle, 30° angle, and we got this A, B, and C. Okay, and we have loading of around Newton here. Okay, so I'll repeat the question. Listen carefully. The axial force in the member CD you are supposed to calculate. This is your point D. Okay, so in the member CD, I am using the red pen to highlight it. In this member CD of the simple truss supported and loaded as shown in this figure, you are supposed to calculate it. Okay, so what is the first step? What is the first step you have to do? You have to calculate the support reactions. Okay, but if you look into this problem, that is actually not needed. Okay, in bigger problems that is needed. This is very simple, because here if you directly draw, um, because the member which they are asking us to calculate the force, in which that member is not connected to the support. Okay, the CD member is not connected to the support. So in this case, we can directly draw the free body diagram of joint D. Okay, so if I take a joint D, how the free body diagram will look like? Let's say FDB. This is, and then this is FDA. Okay, and then we have 1000 Newton force downward, and then we have, okay, at 60° we have FCD. Okay, is it clear till this? Are you following how I have drawn the free body diagram of joint D? This is F free body diagram of joint D. Okay, now we need this FCD, force in member CD. Okay, so if you just take, let's say, the two components of FCD will be FCD sine of 60, and this is FCD cos of 60. So you can say that FCD sine of 60 is equal to 1000 Newton. Okay, so FCD will be equal to 1000 divided by sine of 60, and that is equal to 1154 Newton. Okay, so 1154 is the correct answer in this case. And Okay, I will explain you for the diagram once again. Listen carefully. Okay, so I'm drawing the free body diagram of joint D. At joint D, if you see what are the forces are there, one this particular joint D, we have 1000 Newton force acting downwards. Okay, then we have force in the member FDB. Okay, so that is FDB. Force in the member AD, so that is FDA, and force in the member CD, that is why CD. Okay, answer is 1154. Let me take it correctly here. Okay. Yeah, and we have F in the member CD, force in the member CD, which is at 60 degree. Okay, is it clear now, Nima, how the free body diagram is drawn? Any doubt till this? Okay, and then just I am resolving this FCD into two components. One is vertical component and horizontal component. So vertical component will be FCD sine of 60, and horizontal component will be FCD cos of 60. Okay, and yeah, so from equations of equilibrium, summation of all vertical forces equal to 0, we can say that FCD sine of 60 has to be equal to 1000. Okay, yeah. Okay, clear? Yeah. And this member is in tension. Okay, this force is in tension, you can see, because we are pulling from this side and our direction of the force FCD is also going away, so in both the side it is in tension. Okay, so this was a very simple question. We'll solve a couple of more simple questions where we are dealing with a single truss, and then we will make it little complicated. Okay, can I go to the next slide? Yeah, okay, let's take one more question. A truss consists of horizontal members and vertical members having length L each. Okay, the members A, E, D, E, A, E, D, E, and B, F are inclined at 45-degree angle to the horizontal. To stop for uniformly distributed load, load P per unit length of the members member, or let's say on the member, P per unit length on the member EF. Okay, So on EF member, we have a uniformly distributed load P per unit length of the truss as shown in the figure. Okay. Force in the member CD is. Okay. This is the question. So let me show you the figure. Okay. So this is your point A, B, C, and D. These points are E and F. This is uniformly distributed load, and this is L, 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 L. Okay. This is 45 degree. Then this is also 45 degree, and this is also 45 degree. Okay. I hope the question is clear to you. I'll repeat if it is not. The truss consists of horizontal members and vertical members having length L each. Okay, look at this. All the horizontal members and all vertical members are of length L. The members AE, then D and BF are inclined at 45 degree to the horizontal. You can clearly see this in the figure. And we have an uniformly distributed load of P per unit length. Okay, so this is P per unit length. Length is L, right? So um, this is the uniformly distributed load on the member EF. And what they're asking is the force in the member CD, they are asking. Okay. So, yeah. So this is a little bit complicated problem, because if you directly draw the freeboard diagram of, let's say, joint C in this case, okay, what you will get is you will have one force in member AC. Okay. Force in member CD, that is what we are supposed to calculate. And we have one more upward force in member CE. Okay. Is it clear why I'm drawing freeboard diagram of joint C? Because the joint C is simpler compared to joint D. In joint D, we have 4 forces, which makes it a little more complicated. So better to take a freeboard diagram of joint C. We have 3 different forces, and this is our unknown. Is it clear to you? This is what we are supposed to find. But according to equation of equilibrium, the value of FAC has to be equal to value of FCD. But we don't know the value of FAC. How will you find the value of F force in AC? Again, for that, you have to draw the freeboard diagram of joint A. Okay. So you have to draw the freeboard diagram of joint A. And from there, you have to calculate FAC. Then we have one FAE. And then we have one reaction here, RA. Okay. Any doubt till this? Dharmesh, what are the equations of equilibrium? Summation of all horizontal forces equal to 0. Summation of all vertical forces equal to 0, right? So according to the equation of equilibrium, or summation of all horizontal forces equal to 0, FAC plus FCD has to be equal to 0, right? So the value of these two forces has to be equal, just in opposite direction. Okay, then their summation is 0. Do you agree? I hope it is clear. We got one question from Dharmesh. Why we are not considering DB? Dharmesh, the DB is, let's say, member passing through joints D and B. Okay, B is not directly connected to the C. Okay, so I am drawing the free body diagram of joint C. This is free body diagram of joint C. So you have to consider the forces, or let's say the members which we are connected to that joint, not the other members. Are you following? I'm not drawing the free body diagram of joint D here. I'm drawing the free body diagram of joint C. So whichever all the members are coming to the joint C, I'm drawing it and showing you the forces. Now, so FAD has to be equal to FAC, but FAC is unknown. Okay, so how to calculate it? And in order to calculate it, we have to again draw the free body diagram of joint A. From there, we can get the value of FAC. Okay. So let's try to solve this question. I'll move towards next slide because we don't have space here. Okay. This is joint A. We have a reaction. Let's call it as reaction at point A, vertical reaction at point A. VA you can write. We have FAC and FAE. Okay. So if you are considering FAC in this direction, so it will have two components. The FAE will, because this is at 45 degree, sorry. Since this is at 45 degree, it will have two components. FAE cos of 45, that will be the horizontal component, and FAE sin of 45, that will be the vertical component. Okay. So VA is equal to, so direction of this has to be in this direction. Do you agree? Because we have the vertical reaction support is vertically upward. So the this is this the FAE has to be downward, because then only we'll have two components like this. Okay, so this is FAE cos of 45 and this FAE sin of 45. So VA is equal to FAE sin of 45. Okay, this equation, and one another equation is FAC is equal to FAE cos of 45. Okay, so this is what we can call it as equation number 1. Okay, we got one question from Sujana. Why is the direction downward? So Sujana, can you tell me how the reaction at the support A and B will be, whether it will be downward or whether it will be upward? It will be upward, right? So if this reaction is upward, then if you draw the free body diagram of joint A, what should be the direction of FAE? If I draw FAE like this, then the component of let's say FAE cos theta will be in this direction, FAE sin theta will be in this direction. So VA is equal to VA plus FAE cos of theta equal to 0. So what is meant by VA? VA is equal to minus FAC cos of theta. So what this minus indicates? The direction which we have considered for let's say FAC, or let's say VA is equal to, or minus VA is equal to FAC cos theta. What does this indicate? This indicates that the direction which we have considered for FAC is incorrect. That is why we are getting minus answer, and then you can correct it. Okay, So rather than doing this two-step, I have directly written it. I expect you to imagine it, because if you have upward force, in order to balance that, you should have downward force, and that is possible only when we have, let's say, direction downward. Is it clear, Sujana? Yeah. So let me rub it. So we got these two equations. Yeah. Now coming towards the reaction, can you tell me the reactions at this support? Can you tell me the reactions at this support? What is the reaction at point A and B? The P is, let's say, load, then PL by 2 will be the P multiplied by L will be, let's say, um, a point load acting at the center. If you can, if you can replace this with a single force, which is equal to P into L, right? Okay. Then PL by 2 will be the reaction at each support. Do you agree? This VA and VB has to be equal to PL by 2. Okay, correct. Now, yes, so VA is PL by 2, and that is equal to FAE sine of 45. Okay. From this, can you calculate FAE? FAE is equal to PL by 2 sine of 45.
Sir, can you go to previous slide?
Yeah.
Sir, VA plus VP should be equal to PL by 2. No?
VA plus VB is equal to PL, and VA is equal to VB here, because it's a balanced structure, right? And that is the reason I am directly writing it is like VA is equal to VB is equal to PL by 2. Are you following?
Yes, sir. But
Yeah.
sir, at A point also one reaction force will be there, na? Like it's a roller support. So horizontal
I-
force will be there.
In roller support, we don't have horizontal support. The roller support is free to move in a horizontal direction. If we restrict the motion in the horizontal direction, then only we'll have the reaction in that direction. Okay, so let me explain you here the simple concept. Let's say if we have a hinge support, if we have roller support, and if we have fixed support, what is the difference in this? Roller support don't have horizontal component. Okay, Sham, because it is free to rotate or free to, let's say, move in the horizontal direction. Are you following? But
Yes, sir.
in the, so it will only have vertical reaction, because we are restricting the motion in the vertical direction. Okay, but in hinge support, we are not even restricting in the vertical direction, but also restricting in the horizontal direction. So that's why it will have both horizontal and vertical reaction. And here, both of them are free to, let's say, move, or like a pin joint, right? They can, these beams can, let's say, rotate about the joint. So there we don't have any movement. But if you look into the fixed support, here we are not even applying restriction in the vertical direction, but also in the horizontal direction, as well as we are not allowing to move like a pin. So it will have all these reactions, not even vertical, horizontal, but also the moment. Is this concept clear to you, Sham?
Yes, sir.
Sham, what is your doubt? Can you tell me? I can specifically, let's say, explain you. Okay, in the meantime, I'll ask. Okay. Okay, Sham. In roller support, can you tell me in which direction we are restricting the motion? In horizontal or vertical? In vertical. So in whichever direction we are restricting the motion, in that direction we'll get the reaction. That is the very simple logic. Okay. So here in roller support, we have only vertical reaction. We don't have horizontal reaction because it is free to, let's say, travel or free to move in horizontal direction. Okay. In pin joint or a hinge joint, we have restriction, or pin support, we have restriction in both horizontal and vertical motion. So that's why we have both horizontal and vertical reaction. Okay. And in fixed support, we have restriction for everything, for movement in x direction, y direction, and for rotation as well. So that's why we have moment as well. I hope it is clear now. Okay, so coming back towards the another doubt of Srijana, how to consider PL. So Srijana, whenever you are considering the let's say uniformly distributed load, okay, uniformly distributed load, let's say if they say P per unit length, then it is equivalent to this load. If this is the length, it is equivalent to P multiplied by L acting at the center of the length. Okay. It is equivalent to, like, it is equivalent to this if whenever you take the um, let's say whenever you want to calculate the reactions. Okay, Sujana's comment is, sir, for uniformly distributed load, if the load acts at the center, then no. Something is wrong with your uh, concept. It is for the uniformly varying load. Why uniformly distributed load should be PL by 2? Uniformly distributed load means looks something like this, right? Whose magnitude is P and length is L. So it is just the area of this rectangle P into L. What you are talking about is the uniformly varying load, where over the length L, your load will be reducing. So in that case, you can replace it with the area of triangle, that is half into P into L. Okay. So this is whatever you are telling is for uniformly varying load, not for the uniformly distributed load. Uniformly distributed load is looking like a rectangle. Uniformly varying load looks like a triangle. And here it is equivalent to, and this equivalent load will act at the center, and here it will act at a L by 3 distance from this. Okay. Not at the center. So that also you should know. Okay. Are you following, Sujana? Yeah. Anyone have any doubt till this? We got any other question? Let me just check. Dharmesh, what is your doubt? You lost your connection. Which part you want me to repeat? Okay, good, you got it. Okay, Weber, you can directly unmute and ask uh, if you want. No mic. Okay, you can type. In the meantime, I'll proceed. So FAE, I hope everyone understood that FAE is equal to PL divided by 2 sine of 45. And what we said in the previous slide is if Okay, we got FAE, but how to calculate the FAC? FAC is equal to, again, if you apply the summation of all horizontal forces equal to 0, what we can say is FAC is equal to FAE sine of 45. So FAC will be equal to FAE, we already calculated, PL by 2 sine of 45 into sine of 45. Sorry, FAE cos of 45.
Also
Let me
45,
correct.
sir.
Yeah, both are same anyway, but still better to write it correctly. And sine of 45 and cos of 45 are same, so we can cancel it out, and hence directly it is PL by 2. Okay, so FAC is equal to PL by 2, and we said here FCD is equal to FAC, so that's why answer is PL by 2. Okay, feel free to ask if you have any doubt. Let me just rub this concept um, which I have told you before for the fixed support, so you will understand this problem. Other things I'll remove which are not relevant for this problem. Okay. What is sine 45, Dharmesh? 0, 1 half, 1 by root 2, right? So 0, 45 degree, 90 degree. So what is sine 45? 1 by root 2, right? And what is cos 45? 1 by root 2. That is why I'm cancelling it out. Anyone have any other doubt? Okay, Vaibhav, in the last question, Vaibhav is asking, in the last question, link CD will in total PL by 2 force, or the same force will act at point D and they add up to produce PL force. Which question you are? Okay, this question. Okay, in the last question, the link CD will in total PL by 2. Okay, let me just complete this question first. Vaibhav, you wait for some time. Let's finish first this and then we'll go back. Okay, let me know if you have any doubt in this question. If this is clear, then we'll move towards the other doubts. I'll wait for one more minute. If you don't have any forces on ED not understood. What is ED? ED is not, we are not considering ED here, Kanishk. Why you want to consider ED here? Can you tell me? What they are asking here to calculate is force in the member CD. So if you, there will be load in each and every member, Ganesh. Okay, there will be load in the member AE, there will be load in the member CD, there will be load in the member DE, FD. All the members will have some load. That doesn't mean you have to calculate everything. What they're asking here is the force in the member CD, and you don't need ED force to calculate the CD force. Are you following? Yeah, and that is the reason we have not calculated it. We don't need it. Because if you draw the free body diagram of joint C, you have just force CD, CE, and AC. Even we are not calculating CE because that doesn't make any sense to calculate. Okay, and the value of it is 0 basically. Okay, we'll see later how. But as of now, we, in order to calculate CD force, we only need the value of force AC. Okay, and in order to calculate AC, we have drawn the free body diagram of joint A, and then we have calculated FAC. Okay, and that is how we have answered this question. If you want to make it complicated, you can draw the free body diagram of joint D as well. Let me show you how the free body diagram of joint D will look like. So it will have FDB, it will have FDF, then it will have FDC, it will also have as you mentioned FDE, okay, which is at 45. So this makes problem a little complicated now, because in this case we have only 3 forces, and we clearly got FCD is equal to FAC. So the only one unknown which we have to calculate is FAC in this case. But here now, if you consider the joint D in the beginning, in order to calculate FCD, you have to deal with other two unknowns, FDB and FDE. Okay, and that makes life complicated. Are you following, Kanish? That is the reason we are not going into this difficulty. You have to use the common sense here, which joint I should be using in order to make the problem easier and solve it. Okay, I hope it is clear. Yeah, anyone have any other doubt in this question? Okay, if no doubt, then I'll come back to your doubt, Weber. Yes, so let's come back to the previous question. The link CD, what is PL by 2 force here? Here we are not writing anything P or, okay, the same question. Okay, yeah, the link CD, PL by 2 force. The link CD will have PL by 2 force. That is what we have calculated. Weber, what is your doubt? I'm not able to understand. That is the question, force in the member CD, and our answer is PL by 2 for it. I think you are little bit confused here. Don't consider these joints are like the forces are in the members are carrying the forces, and the joints are like these are like just joints which are joining the members which will carry the load. Okay, I hope you are following. So from, let's say, from these joints, load will pass from one member to other. They are like connected through the joint. We are interested in finding the forces in the members. Okay, okay, let me give you some simple questions. It looks like you most of you have, let's say, might be studying this for the first time, or not aware of, not much aware of the trusses. Let me give you some simple questions first, and then um, we'll make it little more complicated. Consider a truss PQR loaded at P with a force F as shown in the figure. The tension in the member QR is options. Okay, I'll not. Okay, let's take the options as well. Make you feel comfortable. Okay. Okay. So PQR is a truss and it is loaded at point P with a force F as shown in this figure. And what they are asking is the tension in the member QR. So let me highlight the member as well. So solve this problem and tell me the answer. I'll give you 2-3 minutes and I'll wait for your reply here. F by 2. No. Yeah, option B is correct in this case, Abhishek. Yeah, you are right. Yes, yes, one. 0.63F is the correct answer. Let's solve it. So, yeah, Sanjeev, correct. So what we are supposed to calculate here is force in the member um, QR. So either you can take point Q or point R as a let's say. So if you consider the point Q, how the free body diagram will look like, you have one force this in this direction, one force in this direction, and one upward force. If you take point R, same, we have one vertical force, we have one horizontal, that is FQR, which we are supposed to calculate. Okay, and we have one force in this direction, that is FPR. Okay, So whichever you want, you can take, because in this case, both are similar. So what we want is FQR, right? So if you focus here and here it will be FQP. So in order to get FQR, we either need FQP or we need FPR. Okay. So either we need force in this. If you consider joint Q, you need force in this, let's say QP, or if you consider joint R, you need in the force in the PR. Okay. So ultimately you have to analyze the joint P as well. So first let's analyze the joint P. Okay. The free body diagram of joint P looks something like this. F force is acting, then this is F PQ, F PR. Okay. So if you just, let's say, apply the equations of equilibrium here, F PR sine of 30 plus F PQ. Or let's write first summation of all horizontal forces equal to 0. F PQ cos of 45 is equal to F PR cos of 30. Is it clear? So from this FPQ, you can write it as F PR cos 30 divided by cos of 45. Okay. And now take the summation of all vertical forces equal to 0. So the value of F has to be equal to F PR sine 30 plus F PQ sine 45. But PQ we have already calculated, so that I'll directly write F PR cos 30 by cos 45 into sine of 45. And sine 45 cos 45 same, so it will get cancelled. FPR you can take common, and sine 30 plus cos 30 will get. So in short, you will get FPR is equal to 0.733 times F. Okay, so this is how you will calculate the FPR. 0.73 point times F, and the cos component of it has to be equal to, this is 30 degree, the cos component of it has to be equal to FQP. Are you following? So what is FPR? Let me draw the free figure again here. This is joint R. This is FPR. Here we already have F. RQ. Okay, RQ is in this direction. And the vertical reaction. So if I split this force, that is FPR, into two components, this will be FPR, this 30 degree angle, sine of 30 degree, FPR cos of 30. So whatever direction we have chosen for RP is incorrect, or left. FQR, it has to be like this. So FQR, we should write it as FPR sine of 30. FPR we already calculated 0.73 times F into cos of 30 into cos of 30, and that is equal to 0.63 times F. Okay. That's why option B is correct in this case. Okay, I'll repeat the procedure once again. Listen carefully, those who have not understood. Okay, so in this case, let's start with, we have started with let's say freeboard diagram of joint R. At joint R, we have vertical reaction because of the support. One horizontal force in the member QR, that is what we are supposed to calculate. Okay, and force in the member PR. In order to get the force in the member QR, we need cost component of FPR. Just by looking into the freeboard diagram, we can see. So in order to find FPR, we have to draw the freeboard diagram of joint P. Okay, from the joint P, if you equate the horizontal forces, the cost component of FPQ is equal to the cost component of FPR as per the equilibrium. So that's how we can calculate FPQ as FPR cos 30 divided by cos of 45. And then the force F, which is acting downward, has to be equal to the vertical component or the sine component of FPQ and sine component of FPR. And that's how we have written it like this. And from this, we got the value of FPR, which is 0.73F. Okay. And then again, coming back to the freeboard diagram of joint R, the cost component of FPR, which we have just calculated, has to be equal to the FQR. Okay. And that's all we have done. Okay. Any doubt in this question? Is it clear to you? It's good. Now, let me give you one more question. The figure shows pin jointed loaded at point by hanging a mass of 100 kgs as shown in the figure. The member ln of the truss is subjected to the load of okay, and you type the answer. Okay, J K L M N Okay, I hope the things are clear now. The figure shows here the pin jointed plane truss loaded at a point M by a hanging mass of 100 kg as shown in the figure. The member Ln of the truss is subjected to the load of. Okay, the force in the member Ln you are supposed to calculate. Angle, okay. Hmm. Take all angles are 45. Yeah, this is 45. Kind of symmetric figure. So it's kind of cantilever truss. You can see like how the cantilever beam will look like. Something like this, right? So same way, it's a cantilever kind of truss. You might have studied or seen this kind of in your basic civil engineering subject. Anyone? Not difficult. It's very, very simple question. Okay, I'll give you options. The Ln, member Ln. Yes, correct H1. 0 is the correct answer in this case. Why? Because draw the freeboard diagram of joint L. If you draw the freeboard diagram of joint L, you will realize that you have, let's say, FLN, FLM, FLK. Okay, this is all there. So if you apply the summation of all vertical forces equal to 0 and summation of all horizontal forces equal to 0, in the first equation, summation of all vertical forces equal to 0, you will realize that FLN plus you don't have any other force. So FLN has to be 0. Okay, so that's why option D is correct in this case. So the member Ln will not carry any load. Okay, clear? Okay, let me give you another question. Is it clear? Can I move to the next slide? Uh, Okay, draw this figure. 2 meters, 2 meters, 2 meters, 2 meters. Okay. The force in the member 1. Okay, so this is member 1. So write down here A, B, C, D, E, F, G, H. Force in member 1. Member 1 is already shown to you. In that member, you have to calculate the force. The inputs are like this. We have 20 ton force, 20 ton load is there. Then we have 16 ton bottom. We have load P here. Then we have 16 ton. We have 20 ton. Okay. And the options are 4 ton, 36 ton, 16 ton, 20 ton. And height is also 2 meters here. Okay. With this input, okay, with this input, try to solve this. Force in the member 1. Member 1 is FB. The loading is 20 ton at point F, 16 ton at point G, 20 ton at point D. So, sorry, 20 ton at point H, 16 ton at point B. And we have P loading at C. What is the force in the member 1? Very simple question. Yeah, 16 ton, correct. Because if you take a free body diagram of joint B, F, B, C, 16 ton acting downward, F, B, A, and we have F member in force 1, right? So summation of all vertical forces equal to 0. It means member force in member 1 has to be equal to 16 ton. That's all. Clear? Are you following? Okay, why are we not considering point F, Dharmesh? Yes, again the same mistake you are doing. So if you take point F, consider point F and draw the figure. If you consider point F, what forces you need? F A F F A F in force in member 1, okay, or let's call it as FFB. Then we have FFC, and then we have FFG, and then we have 20 ton. Which is simpler, Dharmesh? Which um, joint is more simpler? Yeah. So that's how you have to choose. You have to make a decision. Yeah. Okay. Can I move towards next slide? Yeah, okay. Let me give you another question. For the truss, shown in the figure, the force in the member QR is okay. Look at this figure. We have a truss shown in this figure, and the force P is applied at point S. And what they're asking is the force in the member QR. Okay. Force in the member QR. Angle 45 degree. So this is basically also L. Rather than giving angle, this both the height as well as length is L. Yes, Abhishek, P is the correct answer. If you look into this, let's say figure, you have, in order to calculate the force in the member QR, you either need to draw the free body diagram of joint Q or joint R. Comparatively, joint Q I feel is easier. Why? Because if in the joint Q you have FQR, then we have a horizontal reaction at Q and vertical reaction at Q. Okay. So if you get the horizontal reaction at Q, that should be the value of FQR. And how will you get the horizontal reaction at Q? Summation of all, let's say, moment at point, let's say T, if you take, you will get it. So moment at T has to be equal to 0, right? So what is the summation of moment at point T? So we have, let's say, horizontal reaction here, HQ, VQ, maybe VT, HT, okay, whatever direction, okay, but we do have these kind of loads, right? So what we understand from this is, if you take moment about point T, P into L has to be equal to horizontal force at point, horizontal reaction at Q into L. Okay, this is clockwise and this is counterclockwise, so LL will get cancelled. P is equal to HQ. So if HQ is equal to P, means FQR also has to be equal to P, because FQR is equal to FQ. because the summation of all horizontal forces equal to 0. Are you following? Yeah. Okay. Good.
Excuse me, sir.
Yes.
Sir, can I do like that? We will remove the TS because in a TS the force will be zero, no, sir.
In the TS, force will be 0. Okay. So, but what is use of it in order to calculate the force in the member
The,
QR?
then that, sir, at a P it will be like PS and a QR at a 45 degree. Then whatever we force in a PS that will be in a QR also because this is in a 45 degree now.
In the P is the load. P is the load acting,
PS
not. So what
PS
you are
is
saying,
sir, whatever
you
we
want
load
to
in a
remove
PS
this.
that
Okay.
will be same as
What
yes,
you are
yes, sir.
saying, you are removing this, right? So
Yes, sir.
whatever load in the
Then and
S,
yes,
whatever load is in the RS, where that will go? That will
same
distribute
will
in
be
these two, right?
yes, sir. That
So this load,
uh, whatever will you load in a RS will be same as a QR, no, sir. Because it is it at angle of 45 degree, no, sir.
uh, I didn't get your logic here. Um,
Sir,
you want
actually,
to,
I'm saying that, sir. At a R, sir, we will make a bid at R. The force
okay,
will
you
be at
can
a
make. Yeah, same thing you are doing. I did it for Q, then you can do it at R. So what you have is you will have this F R T, then F R Q, and this will
this
be
will be
P.
P.
P. Yeah,
Yes, sir. Yes, sir.
yeah.
Okay, sir.
So
Thank you.
then you solve it, but you are bringing two more unknowns here. Okay, you have to find the FRT, and the cost component FRT has to be equal to FQR. Okay, so it is again same difficulty, right? So and in order to find FRT, what you have to do is you have to draw the freeboard diagram of joint T now. So same thing you'll do, but rather
Sir,
than doing that,
hello.
I just yes. How will you
Sir,
find
it is
FRT? Can you tell?
sir. I am not able. I'm not going to find the FRT, sir. I will just. This is at angle 45 degree, no, sir.
Which is at angle 45? This is at 45. Okay. Huh?
That's yeah, yeah, whatever will yeah, force will in a RS that will same in a QR also, no, because the
Why?
resulted is at a 45 degrees, sir.
Yeah. Okay. So okay, in that way, you are saying that FRT in
Yes,
this
sir.
case is resultant. Okay.
Yes,
What
sir.
if I make this angle as 30 degree?
Then it will be complicated.
Yeah. So yeah, don't make it as a general statement like because in this particular case, yeah, uh, you whatever your logic is maybe correct, but uh, the approach I feel is not in the correct direction. What I feel. So here you should know the FRT, right? What and according to you, what you are saying is like this is a resultant of. But even if you don't know the value of FRT, okay, so you cannot conclude. Let's say so. Okay, it is at 45 degrees, so that's why you're saying the angle is tan of 45 is equal to 1, so this value has to be equal to 1. Yeah, I agree with that, but ultimately if the angle is different, then you have to calculate FRT, right? And how you'll calculate FRT, you have will draw the freeboard diagram of joint T. Okay, so it
Sir,
it will, yeah.
sir, if the angle is something another like that 30 degree, no, sir, we can also use the tan theta like that, no, sir. If this angle is 30 degrees, sir, then The another angle will be 60 degree, sir. We can find 10,
Yeah,
60
you can.
degree.
Yes, you can do like
Yeah.
that. No problem. Yeah, but
Okay, sir.
ultimately, what I'm saying is like you have to. Yeah, in the beginning itself, I said you can either choose point Q or R. Okay, so yeah, if you are
Okay,
interested in using R point, you can go ahead with that logic, and you can, if you feel that easy, you can do it. Okay, that is also
okay.
correct.
Thank you.
Uh, um, in each problem, I'm saying the same thing, that if you remember the um, all the problems in whichever, let's say, remember we are supposed to find the force, either we can draw the free body diagram of, let's say here QR is there, either you can draw the free body diagram of Q or free body diagram of R. Okay, same approach we are following everywhere, but ultimately it's a choice of everyone which you feel easier. Okay, so in this case I feel it is very simple. If I directly say HQ is equal to QR, I don't have to deal with any kind of angles. Okay, because FQ is also horizontal and FQR is also horizontal, so both of them has to be equal. And if you calculate FQR, if you calculate let's say moment about point T, you will get the value of HQ. Okay, anyone have any other doubt? Okay, um, Ranjan, I'll explain you the last part once again. Listen carefully. I hope you understood that till this part, that is HQ is equal to F, FPR, sorry, FQR. Okay, HQ is equal to FQR. So you are supposed to find HQ. How will you find HQ? HQ is the horizontal reaction at point Q. So if you take the moment about point T or joint T and equate it to 0 according to equation of equilibrium, then you will get the value of HQ, because VQ will not create moment because both are on the same line. So VQ will not create any moment. HT and VT are also passing through point joint T, so they will also not create any moment. So the only loads which create the moment at point T are this load P, which is at a distance L. So P into L is a clockwise moment, and HQ into L is a counterclockwise moment. Both of them has to be equal. Then only moment at point T will be 0. So if they are equal, then LL will can cancel and HQ will be equal to P. And if HQ is equal to P, FQR is also equal to P. Okay, so the answer is P. Okay. Ganesh, you have any doubt? Something you have mentioned R multiply by N. I don't know whether it is for this question or the previous. Okay, wait, Madhu. We'll first complete this and then we'll go to the previous question. Yeah, I would encourage you to ask question during, let's say, whenever we are solving or once we complete it, because in between I cannot go to the previous question. You have to complete it first, then only we can go. Okay, so make that habit of asking the question. Do not hesitate to ask, but you should ask it whenever we are dealing that question. Okay. Okay, we got question here from Kanishk. HT direction. What you want to take? You want to take HT in horizontal direction, this direction? Take it, no problem. See, don't worry about the direction. If you're in answer you are getting negative, means whatever direction you are considering that is incorrect, you have to just change it. Solve the question. I am changing the direction of HT now. Whether it will change or not, tell me. We are taking moments at point T, Ganesh. So irrespective of direction, if they are passing through point T, they will not create any moment, right? So we are not considering HT in anywhere in the calculation. Are you following? See, don't get confused for the direction. Even if you, let's say here, someone will say why HQ direction is kept in leftward direction. Can I take it in rightward direction? Yes, you can. But see what will happen. If you take HQ in the rightward direction, what will happen? You take a moment about point T and equate it to 0. P into L plus HQ into L has to be equal to 0. What does it mean? P into L is equal to minus HQ into L. So P is equal to minus HQ. Okay, so HQ will be equal to minus P. Minus sign is coming means whatever direction we are considering is incorrect, we have to correct it. Are you following? So that is the reason I have already drawn in this direction. Make some, let's say, think it like in a general way, common way, like apply your understanding, simple logic or common sense here. If we have clockwise moment created by force P, what should be the, let's say, the balancing reaction? It should be counterclockwise. And when we get a counterclockwise moment, when the direction of HQ will be in this direction. If it is in this direction, again it will create clockwise, right? So it will not balance out, and ultimately will get minus sign, and you have to correct it again. Is it clear to you all? At least the direction side, how we have to decide. It's good. Okay, is this question clear to you all? Anyone have any doubt? Okay, then I'll go to the previous slide where Madhu was asking some question. Is this the question you are asking, Madhu? What is your question here? Okay. The question was for LN, not for LM. Okay, I hope till this things are clear to you. Let me give you one more question. What is the force in vertical member CD? Of the pin jointed frame shown below. Options: 2 ton, 5 ton, 7 ton, 12 ton. Seven ton, 5 ton. E, B, C, and D. Okay. What is the force in the vertical member CD of the pin jointed frame shown below? Options are 2 ton, 5 ton, 7 ton and 12 ton. Two, 5. What are the other answers? Yes, 5 ton is the correct answer in this case. Draw the pre-bar diagram of joint D. F, D, E, F, D, A, F, C, D, or let's say F, D, C, and this is 5 ton. So the link, sorry, in the member F, in the member CD, the force will be 5 ton only. If you apply summation of all vertical forces equal to 0, FCD or FDC, whatever you name it, equal to 0.
Sir,
Okay. Yes.
so in pin joint there will be two reactions.
The don't get confused in between. Let's say supports and joints. This is your hinge support or pin support, you can say. Okay. I'm not saying these are, let's say, supports. Okay. This is just a single truss you are getting, and you are supposed to calculate the load in the member CD. And even if yeah, and even if you have horizontal load, that doesn't change the answer. Okay, because we do have FD and FD as horizontal loads. Still your answer. What I am asking you is in the vertical direction, what is the load? Okay. This is not support, first of all. Okay, this is not the support. This is the joint. If you draw, either you can draw the freeboard diagram of joint D, or you can also draw the freeboard diagram of joint C, but again you will make the things complicated. Why? Because at point C you will have 7 ton acting downward. Okay, you will have FCD, and then you will again have FCA and FCB. So basically this 7 ton will get distributed along these three forces. Okay, and we don't know the values, so we have two unknowns. We have three unknowns basically. So this is complicated if we choose the point C to solve this problem, and that is why we are using um, the point D here, because here the things are simpler. The CD is the member which will carry the load, so you can either choose point D or point C, whichever makes the calculation easier. Okay. Okay, we got some question from here from Nima. Why we are ignoring 70? We are not ignoring 70, Nima, here. Okay, 70 is acting at point C, and that is distributed along FCA, FCD, and FCB. Okay, I'm not saying that the this part of 70 will be there in the FCD. Okay, so basically, you don't know. Okay, you don't know the FCA and FCB here, you cannot make any conclusion unless and until you calculate these two loads. Are you following, Nima? Whenever you calculate FCA and FCB, then only you can make some conclusion for FCD if you consider the joint C and the 7-ton load. But there is no way here to calculate FCA and FCB. That is the reason we are considering joint D. In joint D, we can clearly see we have only one force in the vertical direction, that is 5 ton, and the balancing force in the member CD has to be equal to 5 ton. Okay, then only it will be in equilibrium. Okay, so that's why 5 ton is the correct answer in this case. So yeah, that's all we have for today. We have studied the method of joints. We understood how truss structure looks like. In the next session, we are going to study method of sections in order to solve the truss problems. Okay, so we'll have in tomorrow's session will be one more session. We'll focus on trusses. Okay, if you have any doubt till this, feel free to ask. Otherwise, we'll end our session here. Okay, thank you all. Bye. Good night.